So I've got questions 1 and 2 pulled up together. And the key difference here is that if you have a number to a variable, which is typically like a number to the power of x,
Mhm.
something like that, that is different than a variable to a number. That's something like x to the power of 3. Do you see can you see the difference between these two on the right here?
Yeah,
They're very different. Like you're used to these on the bottom here,
yeah.
variable to a number, but now we're moving into the land of numbers to variables.
Mm-hmm.
So you have to look at this over here and decide. And they've made this one somewhat confusing because they put a number in front of x, but imagine that -2 wasn't there. What would this be?
Just 3 to the power of x.
3 to the power of x, right? And that is an exponential.
Yeah.
So exponentials have a number to a variable, and then polynomials, or in this case, this is so polynomial is very general. It could mean x to any power. This is a quadratic because it's to the power of 2.
So, um, so for number 2, I would have to write it's a quadratic, and like you said, because it's to the power of 2.
Yes, yes. On the
And
right is sort of like the notes you would have been given in a classroom with some examples.
mhm. I did not I feel like because this is a new thing, uh, when I looked at number 1, I was like, okay, it's just the same thing as number 2, except the x is in parentheses with the power of 2. But it was
It looks the same, but it really is very different. And it's you gotta kind of decide, is it a number to a variable or a variable to a number? Or
yeah,
number to x or x to a number?
yeah. I didn't hear what you said for the first one because I only wrote the reasoning for number 1. Could you, because I'm still a little bit confused for number 1 exactly. Like, because at
It,
this time it's numbered to variable.
that's it. That's all it is. I mean, there's no other explanation. It's in this form of a number. So the 3, I guess the 3 is called the base,
Mm-hmm.
and this up here is called the exponent.
Yeah.
When the exponent is a variable or has a variable in it, then it's exponential.
Mm-hmm. Okay, I got it.
Okay, so let's look at number 3 now. All right, so it says evaluate g of 4 when g to the x equals 3 to the x plus 1. That means you're putting 4 in for x. Wherever you see an x, you're going to replace it with a 4. So first start by writing it down with the number replaced for x.
Mm-hmm.
And now it's order of operations.
Right.
Okay,
PEMDAS.
so yep.
What
So what
PEMDAS?
do you see any parentheses?
Yes, it's in the exponent. So you
So
would
you have,
do, so it'd be 3 to the power of 5
okay,
minus 3. Next,
and
you do
then
exponents.
okay. So
I'm
if you're not sure what that is, go to the calculator.
Yeah, that's what I'm doing because Desmos. That would be 243 minus
Good,
3,
good.
which equals 240.
Now it does say to like do this show as this as in the example above. So I guess I better look to see if there's something else that they're looking for here. We should said which example because there's several here. Yeah, I think we're okay, but I don't want you to get this brought back in. All right, let's just keep going.
All right.
We'll do number 4 next. Let me snip it in. All right. Evaluate j of 0 when j of x equals -2 times 3 over 2 to the power of x. So just if I write this just a little bit better, it's 3 over 2 to the power of x like that. That's j of x. And we're putting 0 in for x.
Mhm,
-2 to the 3 over 2 to the 0 power.
mhm.
So we know to do the exponent or evaluate the exponent first, and what you should have been shown at some point, either this year or last, is that anything to the 0 power, doesn't matter what it is, becomes 1.
Oh, I think I've heard it last year. Yeah.
Okay, so there's a bunch of exponent rules to remember. This is one of many. That means that this 3/2 to the power of 0 is just 1.
So when we're doing PEMDAS and it's just 3/2 to the, it's still going to be just 3/2.
No, the 3/2 is the x. X represents whatever's underneath.
Oh, okay. I'm sorry. I got confused for a
Yeah.
second.
So this whole thing, 3/2 to the power of 0 becomes 1.
So -2 times 1 is -2. So that would be our answer.
That's it.
I'm getting the hang of them. Thank God I read the lesson beforehand.
And do they have videos with the lesson or just reading?
No, they also have videos.
Which do you prefer, reading or the videos or both?
I prefer both.
Good. Okay, so one of the things that really important to remember is that whenever you're substituting for variables, they're really in parentheses.
Hmm.
Okay, and it becomes more important when the number you're substituting is negative,
Right.
which is the case here. So f of -2 means 3 to the power of minus parentheses -2. Notice that's an exponent, and I'm writing it way up above the number. Like I'm doing it way more emphatically than
Yeah.
this. And like you probably do this when you're doing other sports. Sometimes you do things like more extreme to get the like feel of it. Like we really want to make sure that this is way up here so that you know that it's an exponent. All right. The reason I do it this way is I don't want you to lose that negative because you do have to negate whatever number x is.
Hmm.
So it's 3 to the power of 2 minus 2. And 3 to the power of 2, very important. It means that it's 3 times 3,
That would just not.
which is 9. It's not anything else. It's the number times itself, the number of times indicated in the exponent.
Yep.
That's 9 minus 2.
Which is 7. So 7 would be our answer.
Yes.
All right. Number 6, right? Yeah.
Yes. Yeah. You know, and in full disclosure, you could go right to a calculator and determine these, but
Yeah, but
I
I don't
think
want to do that because that's not going to help me learn it better.
exactly. But if I wasn't here, you could, for example, work it out, and then we could go to a calculator and try it. So I think you know enough to do this one. You know to do the do inside parentheses first, then the exponent, then multiply, then subtract. So I'd
Hmm.
like you to try this one on your own, please.
Okay. I got 97.
I agree.
Yes.
Well done. Okay, let's continue here. Looks like got some other problems to think about.
The word problems.
Yes. All right, let me snip this one in. All right, Charlie goes to a new car dealership and buys a car for $35,000. The salesman tells him that the car depreciates 20% of its value every year as soon as it leaves the dealership. Charlie wants to know the value of his new car after 4 years. Show the formula, the steps to solve the problem, and then the answer including units of measure. Okay, so the value of the car, we'll call it value of the car as a function of time, is equal to what's called PAT. P stands for the principal or the starting amount.
Mm-hmm.
A is two things. It depends whether it's growth or it's decay. So decay is like depreciation, growth is appreciation, increasing, decreasing. Growth is 1 plus R, decay is 1 minus R. And you might be wondering, well, what is R? R is the rate.
Mm-hmm.
P is the variable. It's time. It's generally in years, generally. Okay. So what does 35,000 represent in this problem? Is it P, R, T?
I'm sorry, what?
What does 35,000 represent in this equation? Is it P? Is it R? Is it T?
I would say that it would represent G.
P, letter P here, you mean?
Yeah.
Okay, maybe you heard something different. 35,000, okay. Now, is this thing growing or not? Bigger or smaller? What does depreciate mean?
I'm pretty sure it means it's getting smaller.
It is. So that's the R. R is 0.2, not 20%.
Yeah.
You have to convert to a decimal. And to convert, you divide by 100.
Mm-hmm.
Okay, so that's 1 minus 0.2 in here because it's decay, we're using the 1 minus R formula. T is the variable. Okay, so it says show the formula. We've done that. That's like part A. Part B is to show the steps to solve this problem. We're interested in the value of the car after 4 years. So that's V of 4. And so what we can do is actually change this to 0.8 inside here to the power of 4.
Okay.
And you can go right to a calculator, but because this is money, how many decimal places do we typically talk about when it comes to money?
Oh my God. Okay. I think the hundreds. Or maybe I'm
Well, maybe when it comes to like talking about cars, I'm talking about you go to the store, you go to Walmart or your local grocery store and you see something on the shelf. It's something
oh
point what?
yeah. Well, in cars it's usually the thousands. Like
But we're not talking about, I'm not talking about, I'm just talking in general, like money in general is to 2 decimal places.
mhm.
You will be driving soon. You'll go to the gas pump. You'll be shocked, but it is to 2 decimal places.
All right.
You go to Walmart or really anywhere, you'll see prices to 2 decimal places. So your answer needs to be to 2 decimal places.
Okay,
So,
so when I put this in the calculator, I got 1.43 433, like 1 point. So
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 this one works out. This one works out perfectly,
mhm.
but we could add in 2 decimal places because it is money.
So it'd be like
Oh, I'm sorry. Oh, you went out. I'm sorry. You went out, or I went out too far. It's 36 point. Get rid of that. It's 14,000. If the comma's in the wrong place. $14,336.00. And you have to include the dollar symbol.
Right. Because we're talking about money.
US dollars. That's important. We're not doing it in euros. We're not doing it in Bitcoin.
Thank God. Euros is more expensive than US
Yes,
dollars. I know this because my parents once made me calculate stuff in
good.
euros. So
I
now,
like it.
yeah.
Okay, let's do number 8. Looks like only 8 questions in this assignment. That's good.
I know. I was shocked when I was like, not 10.
Rebecca goes to the bank with $2,000 she has saved over the summer. The bank advertises a 3% interest rate when opening a savings account. The bank compounds the money daily with an exponential formula. So this is sometimes referred to as PERT, PE to the RT PERT, where P represents the initial amount deposited. E is, this is pronounced Euler's constant, approximately 2.7128. R is the rate in decimal form, and T is the total time. Rebecca wants to know how much money will be in her savings account after 10 years, assuming she doesn't withdraw any money, of course. All right, so show the formula, the steps to solve this problem, and the answer, including the units of measure. So here's what it's asking for. We're going to start by writing the formula PE, PERT, PE to the R times T power. That's in the exponent.
Mhm.
P is the starting amount. What is the starting amount in this problem? How much is she starting with?
She's starting with $2,000.
$2,000. Okay. R is the interest rate, but you cannot use it as a percentage. You have to convert it to a decimal.
Oh, yeah, decimal. Oops.
So what would that be?
uh, that'd be a 0.3.
0.3 is 30%.
Oh, sorry. 0.03.
So remember, you divide by 100,
Yeah.
0.03, okay? And then T is how many years in this case?
10 years.
10 years, yeah. And kind of oddly enough, well, I don't think you have to do that. So we're going to rewrite the formula here with T in it, but it's going to be 2,000 E 0.03 times T.
All right.
All right, so now we're going to evaluate for T equals 10. We're going to put 10 in for T.
All right. Okay.
So your Desmos will have an E button in it. It may be under func,
Okay.
and it'll be the E to the X. They're kind of in the middle right. Let me know if you need help finding that.
I found it.
Fantastic.
That's a big number. Oh, so I put it in the calculator.
Okay.
My God, 2,699.71. I'm not sure if that's right.
You have to round to 2 decimal places. So take a look at your rounding.
Okay.
There's a small error in your rounding.
So it would be 70.
So what I see is 717.
Yes.
So does that 7 on the right cause this number to the left of it to round up or round down?
Well, it rounds up, so it'd be 72.
Yes.
All right. I thought I got the calculations wrong and I got scared for a moment.
The rounding is really important. I mean, if you did a bunch of calculations all day long and you were off by a penny here and there, it could really be a problem.
Yeah, my dad's a
'Cause,
real estate agent and he knows this like when it comes to auctions for houses, I would say.
yes, in that world, there's a lot, you may be talking about more than a penny, but it's important. It's really important to have the correct amount. Everyone needs to be in agreement, buying, selling, and so on. All right, so I think that takes care of that assignment. Let me just look at it one more time because I don't want you to.
Okay, I'm not gonna take a photo of it to cam scanner just yet
Okay.
until double check it to make sure it's good.
Just looking to see if there's anything else just to show the steps. I mean, you've done that. If you've written down, 80% of what's here, it should be fine. If you've written down everything, that will be even better. I think it's okay. I'm surprised there's only 8 questions, I guess.
I can't believe that it was just 8 questions today still. I think this might be my favorite lesson though. I liked it a lot.
Yeah, it's good to be done with something sooner. So we can keep moving on whenever you're ready. We'll move on to the next lesson. Just let me know.
Yeah, okay. All right, I'm ready for lesson 22.
All right, sounds good. So we're going to need that Desmos graphing calculator.
Oh yay, I have not seen the graphing calculator in so long. Sorry.
Right, that's okay. So given the function f of x equals 3 to the x, they're telling you it's a growth function. That's
Mhm,
nice. And we have to decide its domain and its range. Okay. So on the graphing calculator here, let me go ahead and I guess I should show you a few things that could be useful. So let me go to share uh, the graphing calculator that we have high regard for. So y equals 3 to the power of x. Okay, you can see that in red there. And if we go left, do you think that it ever crosses the x-axis? Like if we zoom in, see how it doesn't, it's like approaching it. And if we come over here and we zoom in,
yeah,
do you think it ever crosses?
no. Well,
It
I mean,
doesn't look like it. It doesn't look like it. So,
it doesn't look
um,
like what it looks like. It just a little curve. It's a little nice turn.
right. So I'm going to do something here. I'm going to, what am I going to do here? I want to change this line a little bit. Settings. Okay. All right. So I'm going to hit the play button here and I want to actually not make this go. We'll just go out there. That's fine. It's got a little more. Okay. I'm going to hit the play button and tell me what you see with that horizontal line and the red line, red curve.
With the red curve.
Yeah. Tell me, kind of give me what you see here in your own words.
Well, when you're moving it up and down, the curve never it stays in the same place.
That's right. And do you see that it always approaches the blue line?
Yes.
All right, now watch this. I'm going to change this to a decay function. And let's do the same thing. So notice it approaches that blue, even if it's a decay function. Decay just means it goes down into the right.
Yeah.
Okay. Now what if I get really tricky here and I flip it over the axis? Do you see how that red line just keeps moving with it?
Yeah.
So the summary or the conclusion here is that there's nothing I can do that makes this red curve cross this blue line. There's just no way to do it. Okay. So let's go back to the original here. Get rid of some of this. And let me just graph y equals 0. So I'm going to grab a snip of this and we'll go talk about how to actually write the answer in the problem. Let me go back to it. All right, new share. Sorry, just too many buttons to click.
No, it's okay.
All right, so we're back to the other screen and it's asking about domain and range. So domain, until otherwise stated, is going to be all real numbers. And let me just look at, let's see if your teacher uses interval notation or set builder notation. Interval notation. Okay, so your domain is minus infinity to infinity. This means that the graph, the red graph, it goes left forever. And believe it or not, it goes right forever, even though it looks like it's going up. It's always going to the right.
Mm-hmm.
The range, though, depends on this blue line here. There's really no number that's being added to it. There's really a +0 there, but we don't contribute it. But this line is y equals 0. And the red line, the curve here, approaches it, but never crosses it. And we saw that on the graph. So the range, which goes from bottom to top, is 0 to infinity. It approaches 0, or it starts at 0 down here at this horizontal line, but then the y values go up.
Right. Yeah, I'm caught up, by the way.
Okay. Let's look at the next one here. We'll see if it's different. Yeah, this is the other one. Very similar. All right. So here's what I'd like you to do. I'd like you to graph, go to Desmos and graph y equals 3 to the x, and then graph y equals parentheses 1/3 to the power of x. And I want you to tell me what you see.
Okay. Okay, so when I graph it, so the y equals 3x, it directly passes through both the y and the x-axis, I think.
Does it look something like I've drawn here?
Oh, I know my mistake. Hold on. I made a little mistake. There, yes, now it does.
Okay, great, fantastic. So that's important to see. Now we're interested in the one on the right. Okay, this one that goes to the right here. Do you see that it approaches 0 again? But it
Yeah.
never crosses 0?
Yes.
That's important. That's really important. Okay, so the domain here, the domain until otherwise is going to be minus infinity to infinity. But the range will depend on what's called this horizontal asymptote.
Mm-hmm.
Okay, and the horizontal asymptote is the number that's being added to this, which isn't there, y equals 0. So in this case, it starts at 0. And how high up does it go?
Goes positive. So positive infinity.
Goes forever, yeah.
It never ends.
It does not end.
Yeah.
Okay, that is it for number 2. I would definitely include a sketch of the graph with each of these. That definitely will help with justifying what you did.
Yeah,
Okay,
before I write the domain and range, I make sure that I have since I'm writing on graph paper, it's easy for me to make these mini graphs.
awesome. Yeah, I saw that with one of your submissions. I think that's great. That's
Yeah, it
I
makes
think
my,
math. Go
sorry,
ahead.
you
Oh,
can
go
say
ahead.
it. I was writing graph paper. It makes my handwriting much more cleaner.
Yes, I like it.
Yeah. What were you gonna say by the way? Because I cut
I was
you
going to
off.
say, I wish more students would use graph paper, especially in math. I think it would help because you
Yeah,
can quickly do a sketch, like you just mentioned. You don't have to worry about getting a separate piece of paper out.
yeah. My math teacher in seventh grade, his number one rule was like make sure you use graph paper if your handwriting's not well, or else I will automatically give you a 0 on your homework because he
Wow.
couldn't read my handwriting.
Yes. Yeah. I mean, I understand they're trying to get it so that it's clean. All right. The next graph here is, I want you to go to your Desmos, clear out the other graphs you have in there and just type in e to the power of x. You can use letter E, or you can go to the keyboard, and if you need to go to functions, you'll see an E somewhere, maybe.
It
I would
again
just,
curves. This graph curves again.
yeah, it again looks something like this, right? Goes
You
up,
can see a pattern.
right? So this has a +0, even though it's not written. That is the equation of the asymptote, but more specifically, you want to say the horizontal asymptote is y equals 0.
Mhm.
Now, what does the asymptote tells you? The asymptote always tells you what's called end behavior.
Mhm.
It also helps you with range.
Got it.
So in this case, I think we should just add in the domain and the range. And then we'll add in one other little thing here. So the domain again is minus infinity to infinity. There's no restrictions yet. Now the range, we just talked about it. It's based on the horizontal asymptote. It goes from 0 to infinity.
Again.
Yes. Normally we would see some variations on this, but we're not seeing it in this lesson. So
Mhm.
now the next thing, this is a little bit harder to do. This is something new. We're going to talk about what's called end behavior. I think that's also something it's asking you for. So unfortunately, end behavior is a little bit awkward here. There's two parts. As x goes to infinity, which means as you go to the right, what happens to the y values as you go to the right? What happens to f of x or the y values? What's happening up here? How high up is it going?
It's infinite. It's infinite.
Goes to infinity. And then as x goes to negative infinity, that means to the left. As you go to the left, imagine tracing the curve to the left. What does the y value approach here?
The negatives.
Well, we said it approaches this horizontal asymptote. What's the horizontal asymptote?
Oh,
You see it flattens out here.
there'd be 0.
Yes, f of x goes to 0. Now, unfortunately, I think this is a more intuitive way to write it, but they don't want it in this order. They want it in this order. So they actually want you to say this way, typically, which is just flipping it. If you don't like that, I don't know that there's anything we can do to make it.
No, it's okay. I get it.
Actually, your teacher does. Actually, your teacher does do it that other way. Most textbooks do not. So I guess that's okay. We'll do it like that.
Sometimes there's teachers that are just cool like that.
They get it. Yeah, they say, okay, this is a better way to do it.
They choose the way that the teacher and the kids will understand it the most.
That's ideal. Yeah. All right. So you ready to move on to number 4?
Yeah.
All right.
Yeah, I'm waiting. Let's do it.
All right. There are 2 types of intercepts. It says given function f of x equals e to the x. There's 2 types of intercepts. There's intercepts, x-intercepts and y-intercepts. X-intercepts are when y equals 0, or you can think of it as f of x equaling 0. And y-intercepts occur when x equals 0. And if you recall graphically, an x-intercept means where it crosses the x-axis, and a
Mm-hmm.
y-intercept is where it crosses the y-axis. Do you still have your graph of y equals e to the x up?
Think so, yeah.
Can you tell me if it crosses the y-axis?
Yeah. Okay. No, it doesn't.
The y-axis. Y is the vertical.
Oh, yes, yes it does.
Yes, it does. It crosses right there when x is 0.
Mm-hmm.
So this is calculating f of 0. You're putting 0 in for x, e to the 0. What is anything to the 0 power?
1.
1. So this point right here is 0, comma 1. That's the y-intercept.
Got it.
All right, fantastic. So now, does it have an x-intercept? You already answered me. Does it cross the horizontal, the x-axis anywhere?
No.
No. So the only intercept here is a y-intercept, and that's what you want to express for your answer.
So I wrote like 0.1, not 0.1, I'm sorry.
0,
1
comma 0, comma 1 is the y-intercept.
is the y-intercept.
And you might say that there's no x-intercepts.
Yep. I mentioned that too.
Let me know when we can move on to number 5.
Oh yeah, I'm ready.
All right. So number 5 has a lot of instructions here. They want you to find a number of things. They want you to first make what's called a t-chart, which is only what a t-chart is this is a t, it's x, and then y or f of x, as you prefer. But they tell you you have to use the following x values: -2, -1, 0, 1, and 2. They're saying you have to put these 5 x values into this graph right here,
Oh, great.
or this function, excuse me. What they don't tell you is they don't tell you the order that you should do it in. Like, you don't have to do it in this order. You can do the positives first, you can do the negatives. Doesn't really matter. You just got to get them in there. We are going to start with the negatives. So this is f of -2. You're putting -2 in for x. 2 exponent -2 times -2 plus 3.
Oh, that makes sense. So that'd be 2 to the power of 4 plus 3, which I'm going now to Desmos calculator because I'm too lazy to do it in my head. 2 to the power of 4 is 16, so 16 plus 3 equals 19.
2 to the 4 is 16, so that's 19. So I would like you to find f of -1 for us, please.
Yeah, I got that. So it would be 7.
Okay, very good. And let's do f of 0. Have you do that next.
It would be -1.
Try again here. Try again here. 2 to the power of -2 times 0 plus 3. So you have to multiply inside parentheses first.
Oh, so it would just be 2.
-2 times 0 is 0, and then it's 2 to the power of 0.
2 to the power of 0, but the power of 0 is 1.
The whole thing becomes 1. The base plus the exponent become 1.
Oh, oops. So the answer would be 4.
Yes, before. Good. Okay, now for the next one, I do have to get involved here with so for the next one, f of 1, make some more room here. F of 1 is 2 to the -2 times 1 plus 3.
Mhm.
So this is 2 to the -2 power. Can you go to the Desmos scientific calculator and calculate this for us? And then make it a fraction. There's a button for that. And then I'm going to talk about how that becomes a fraction.
Okay. 1/4. 1/4.
1/4. Yeah, good. Now here's how it becomes a fraction. 2 is really 2 divided by 1.
Right.
The negative exponent means to flip what's inside. So this becomes 1/2 to the power of 2.
Mhm.
The 2 means to square both the top and the bottom, or multiply 1/2 by itself. Either way, it becomes 1/4. So it's your choice. You can either think of it as 1/2 times 1/2, or 1 squared over 2 squared.
I think I'll just consider it 1/4. I don't know.
Say that again.
I think I'll just keep it as a 1/4.
Okay. Well, no, I'm sorry. What I'm trying to show you is that these both become 1/4. Okay. But then you have to bring the 3 down and add 3 to it. So what a lot of students do is they start doing it as decimals because it's easier to graph. Um, so now let's go back to our table, 3.25. So can you find f of 2 this time? And I'm okay if you go right to a calculator. You don't have to do it by hand.
All right. So it would be in the decimals, it'd be 3.06. Well, 3.01 if you round it.
But let's go out as many decimal places as it gives you.
Okay, so it'd be 3.0625.
Good, good. Okay. Now, here, do this for me as well, because I think you'll see this. Do the same thing for 3 and give me the full decimal answer.
Okay. Ooh, that's a big one. Okay. 3.015625.
Okay. Can you perhaps tell me what a value it's approaching on the y here?
I don't know.
Okay, let's look at the graph here. So I've got the graph. What's the y value here that it's approaching?
It's approaching the. It's like I don't know.
Let's count the squares. 1, 3 gridded by 1. What, how much up is this, or how many up is this?
Looks like 0.4. I mean 0.4.
Okay, I'm not trying to make stuff. I'm really just asking you to count squares here. Like 1, 2, 3. What's the y value here of this line?
3.0 or 0.3. That's
It's just a number. Y equals 3.
oh sorry.
So let's go back to the original equation. Do you see a 3 in the original equation?
Yes.
It's right there. That's the horizontal asymptote. That's the value that the graph approaches. Do you
Oh.
see how it approaches that value?
Mhm.
And if you look at the table, these last 3 get really close to 3.
Yeah.
Okay. So this first part concludes what's asked for the t-chart. And the next, it does look like you have to graph this. So what I recommend you do is on a graph, put down probably these points. Those will fit a little nicer. The minus 219 will be tough, but your graph should look something like this when you're all done.
Mhm.
And I would put a dashed line down for the horizontal asymptote.
Got it. Okay.
Okay, so once you have the graph, we can now answer some of the other questions. The next thing it asks for is the domain and the range. The domain is minus infinity to infinity, no change on that. Range, we've done a couple of examples. Could you look back at those and then see if there's anything that you can use to figure out the range of this one, or maybe you know and you can tell me.
Mhm. Well, the range would have 3 in it, but like
Absolutely.
it would be 3 comma infinity.
Good. You got it.
Oh yay.
All right. The next thing it asks for are intercept.
Mm-hmm.
So looking at the graph, does it cross the y-axis?
Across the y-axis? Yes.
It does. That's right. And where does it cross the y-axis?
Uh, the point it crosses where 3 is, so it'd be 3.0.
3 comma 0 is right here in the black dot.
Okay, so it'd be 0.3. I apologize.
0 comma 3 is right there. Is that where the blue curve crosses?
Yes.
The purple one.
Oh
Blue,
no.
blue.
So
So where does
sorry, I'm confusing you and I'm confusing myself.
yeah, we're asking where the blue purple curve
Oh,
crosses.
that'd be 0.4.
Yes. Okay, now let's go back and look. Is that in our table? Is that in the t-chart? Do we have 0, 4 in the t-chart? We do.
Yeah.
So a lot of the information will come from the t-chart.
Ah,
Okay. Now, are there any x-intercepts? Does this purple curve ever cross the x-axis?
no, it doesn't.
So there's no x-intercept. All right, so we do unfortunately have to stop here. We'll just pick up on this problem for next time. I know that we well, fortunately, we have to stop here. I do have to grab a phone call here real quick. So we're gonna stop here. I know that we got a lesson